Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Imagine a retail application depends entirely on one Azure region. That region experiences a major outage. The application becomes unavailable, customers can't complete purchases, and the helpdesk can't simply restart a server to solve the problem. The weakness is architectural. There was no global traffic management strategy and no healthy secondary region ready to receive users. This is where services such as Azure Front Door become important. Front Door can sit in front of multiple application origins, monitor their health, and route requests according to the availability and routing configuration you define. Combine that with resilient regional architectures, and you can design applications that continue serving users, even when part of the environment fails. That's the skill we're building today: global application delivery and multi-region resilience. In Part 7, we went deep on Azure Load Balancer for regional Layer 4 workloads. Now we're going global. By the end of this video, you'll understand how to choose between Azure Front Door, Application Gateway, Traffic Manager, and Azure Load Balancer based on application requirements. We'll diagram a resilient multi-region architecture, configure path-based routing, examine TLS termination and re-encryption, explore WAF integration, and see how health probes drive failover. We'll also look at how infrastructure as code with Bicep can make this architecture repeatable and easier to manage. Most importantly, you'll learn how to explain the design decisions and trade-offs behind the architecture. That's the skill that turns Azure knowledge into architecture ability. Here's the trap most teams fall into. You put an application gateway in one region, say US East, and every user on the planet hits that single point. A user in Tokyo faces high latency because traffic crosses the ocean, and if that region goes down, your app vanishes. Helpdesk can't fix that. Only an architect who pulls in global load balancing can. That's why cloud architects are in high demand right now. Routine IT tasks continue to become more automated, but somebody still has to design the infrastructure behind the applications. How should global users reach the application? What happens when a region fails? Where should TLS terminate? Where should WAF inspection happen? How should unhealthy backends be removed from rotation? And how do you reproduce the environment consistently? Those are architecture questions. Learning global traffic management, resilience, security, and infrastructure as code can help you move beyond troubleshooting individual systems toward designing the systems themselves. That's what we're going to practice in this lesson. Azure Front Door is a global Layer 7 application delivery service and reverse proxy. Instead of users connecting directly to one application region, they connect to Microsoft's global edge network. Front Door then evaluates your routing configuration and the health of the available origins to determine where requests should go. Depending on your design, routing decisions can consider factors such as origin health, priority, latency, weights, and route configuration. Front Door can also provide capabilities such as TLS termination, caching, URL-based routing, redirects, rules processing, and web application firewall protection. Behind Front Door, You may have regional application infrastructure. In some architectures, that regional layer can include Application Gateway. Application Gateway is also a Layer 7 load balancer, but it operates regionally and integrates directly with your virtual network. It can provide regional path-based routing, TLS termination, health probes, connection draining, and web application firewall capabilities. Think of it this way. Front Door handles the global application delivery layer. Application Gateway can provide additional regional Layer 7 control when your architecture requires it. Quick checkpoint. What is the primary role of Application Gateway inside a single Azure region? Pause and think it through. The answer: Application Gateway provides regional Layer 7 load balancing, including capabilities such as path-based routing and TLS termination. It can also integrate with web application firewall when your security requirements call for application layer inspection. That's an important distinction. WAF is an optional capability, not something every application gateway deployment automatically includes. And unlike Azure Front Door, Application Gateway is regional, so it doesn't provide global application failover on its own. Let's put them side by side. Azure Front Door operates globally at Microsoft's edge. It's designed for global HTTP and HTTPS application delivery and can provide capabilities such as edge acceleration, caching, health-based origin selection, URL routing, TLS termination, and WAF. Application Gateway operates regionally inside your Azure networking architecture. It provides Layer 7 load balancing for regional workloads, including URL path-based routing, TLS termination, cookie-based session affinity, health probes, connection draining, and optional WAF capabilities. Here's the important architecture lesson. You don't automatically need both. If Front Door alone satisfies your global routing, security, and origin requirements, adding another Layer 7 gateway may introduce unnecessary cost and complexity. But when you need additional regional Layer 7 routing or security controls inside your virtual network, Application Gateway can become another useful layer. Architects don't ask, "How many Azure services can I add?" They ask, "What requirement does each service solve?" Here's a practical decision tree. First question: is the traffic HTTP or HTTPS? If not, Azure Front Door and Application Gateway aren't your primary choices. For regional Layer 4 TCP or UDP load balancing, evaluate Azure Load Balancer. For global DNS-based traffic distribution, including scenarios that aren't limited to HTTP and HTTPS, evaluate Azure Traffic Manager. Now suppose the workload is HTTP or HTTPS. Do you need global application delivery, edge acceleration, global health-based routing, or WAF at Microsoft's edge? Evaluate Azure Front Door. Do you need regional Layer 7 routing inside a virtual network, such as path-based routing to different backend pools? Evaluate Application Gateway. And if your requirements call for both a global edge layer and additional regional Layer 7 control, you can evaluate a layered Front Door and Application Gateway architecture. The requirement picks the service, not the other way around. Quick checkpoint. A company uses Azure Front Door and wants to reduce direct public exposure of its application origins. What Azure capability should the architect investigate? Private link connectivity to supported Front Door origins. Azure Front Door Premium supports private link connectivity for supported origin types and configurations. That allows Front Door to reach supported origins through private connectivity rather than requiring those origins to accept general public inbound traffic. But don't turn this into a universal rule. Private link support depends on the specific origin type and architecture. Always validate the origin you plan to use against the current Azure front door private link documentation before building the design. Now let's build the full mental model. Users connect to Azure front door at Microsoft's global edge. Front door evaluates its routes, origin groups, health probes, and load balancing configuration to decide which healthy origin should receive the request. Behind front door, we deploy regional application environments. Each region might contain application gateway, app service, AKS, or another supported application architecture depending on the requirements. If application gateway is part of the design, it provides additional regional layer 7 routing and security before requests reach the application workloads. For architectures requiring private origin connectivity, evaluate Azure Front Door Premium Private Link with supported origin types and configurations. The important pattern is global edge, healthy regional origins, regional application routing where required, and redundant application workloads. That's what gives you resilience. Not simply adding more load balancers. A typical web app serves images, API calls, and static pages from a single server. That works until you need to scale and secure each part independently. Path-based routing in Application Gateway sends requests to different backend pools based on the URL path. Here, images goes to an image backend pool. API goes to an API pool. The key is setting the request routing rules type to path-based routing and defining a URL path map resource. That's what turns a basic load balancer into an intelligent, multi-purpose traffic controller. Front door can also route requests based on URL patterns. For example, one route might match API, while another matches the WAF. Those routes can point to different origin groups, but keep two concepts separate. Path-based routing determines which route and origin group should handle a request. Origin selection determines which healthy origin inside that group receives the traffic according to your configured priority, latency, weights, and health status. So you might route or API traffic to an API origin group and or app traffic to an application origin group. Then front door can select an appropriate healthy origin within each group. That's more powerful than simply saying, send this URL to the nearest region. Routing rules choose the application path. Origin selection logic chooses the healthy destination. Let's simplify the TLS path. Connection 1. Client to Azure. Front door over HTTPS. Front door terminates that TLS connection so it can perform layer 7 functions such as routing and WAF inspection. Connection 2. Front door to the regional origin over HTTPS. Traffic is encrypted again before leaving front door. If application gateway is part of the architecture, we can have a third encrypted connection, application gateway to the backend over HTTPS. So visually, think client, HTTPS, front door, HTTPS, application gateway, HTTPS, backend. Each segment can have its own TLS connection, and that's important. Don't assume HTTP is automatically safe simply because traffic is inside a VNet. For sensitive or regulated applications, your requirements may call for encryption across every segment. The architecture determines where TLS terminates and where traffic is re-encrypted. Rewrite rules. Let you modify HTTP requests and responses without changing application code. For example, downstream applications may need information about the original client request. You can add or modify headers that help the application understand how the request arrived. You can also remove unnecessary response headers, such as server, when your architecture supports it. That reduces unnecessary information disclosure about the backend technology. Rewrite capabilities can also help with URL transformations, redirects, security headers, and application migrations. But remember, removing a server header isn't a substitute for patching, WAF, secure configuration, or vulnerability management. It's a hardening measure. The bigger lesson is that Layer 7 gateways can modify application traffic in ways a Layer 4 load balancer cannot. Time for a quick checkpoint. Which Azure services can integrate a web application firewall? A. Azure Load Balancer. B. Azure Front Door. C. Azure Application Gateway. The answer: both Front Door and Application Gateway. The Azure Load Balancer operates at Layer 4 and can't do HTTP inspection, so it doesn't support WAF. Session Affinity and Connection. Draining solve two different problems. Session Affinity attempts to keep requests from the same user associated with the same origin or backend according to the behavior of the service. Azure Front Door supports Session Affinity within its application delivery architecture. Application Gateway supports cookie-based affinity for backend servers within the regional gateway architecture. Connection draining addresses graceful backend removal. Suppose you need to remove a VM from an application gateway backend pool for maintenance. Connection draining can allow existing connections to complete for a configured period while preventing new connections from being sent to that backend. Health probes solve a different problem. They identify unhealthy backends so new traffic can stop being routed to them. Remember the distinction. Session Affinity helps maintain continuity. Health probes detect failures. Connection draining helps with graceful backend removal. Now let's shift from clicking to infrastructure as code. Instead of manually documenting every front door route, application gateway setting, WAF policy, health probe, and backend configuration, define the infrastructure in Bicep. That gives you a repeatable deployment. If an environment needs to be rebuilt, you deploy from the same source-controlled templates rather than trying to remember every portal setting. That doesn't mean every Azure architecture redeploys instantly. Services such as Application Gateway can take time to provision. The value of infrastructure as code isn't instant infrastructure. It's consistent infrastructure. You can review changes, track versions, test deployments, reduce configuration drift, and reproduce the architecture much more reliably than manual deployment. That's the architect mindset. Infrastructure should be documented in code. If you're coming from Helpdesk desktop support or systems administration, you already understand something important: what infrastructure failure feels like to the user. You've seen authentication failures, network outages, slow applications, certificate problems, DNS issues, and confusing error messages. Architecture takes that operational experience and moves the question upstream. Instead of asking, "How do I fix this outage?" you start asking, "How do I design the system so one failure doesn't create an outage?" That's the transition we're practicing. Take the architecture from this video, deploy a smaller version in your own Azure lab, break it deliberately, and document what happens. That becomes a much stronger portfolio project than simply listing Azure services on a resume. Support experience can become an advantage when you move into architecture. Why? Because you've seen what happens when systems are designed without the user in mind. A technically available service can still provide a terrible experience if users receive unexplained errors or applications fail unpredictably. When you design global application delivery, think beyond the load balancer. Think about useful error responses, monitoring, health probes, status communication, failover behavior, logging, and recovery procedures. Architecture isn't just drawing boxes. It's designing how the system behaves when those boxes fail. A production architecture may contain front door, WAF policies, regional application gateways, application workloads, health probes, monitoring, and networking. Infrastructure. As code lets you represent those components in Bicep. For a small lab, you might deploy resources from a resource group scoped template. For larger multi-region architectures, you'll often organize Bicep into modules and may use subscription level or other appropriate deployment scopes to orchestrate resources across resource groups and regions. The important skill isn't memorizing one deployment command, it's understanding deployment scope, resource dependencies, parameters, modules, and repeatability. Once the architecture is represented as code, you can deploy it consistently through Azure CLI or a CI/CD pipeline. That's the real upgrade from manual administration to cloud engineering. Quick checkpoint. Does every global Azure architecture use exactly the same AZ deployment group create command? No. That command is appropriate for resource group scope deployments. Your actual command depends on the deployment scope of your Bicep architecture. Larger environments may use subscription-level deployments or modular deployments targeting multiple resource groups. The interview-level answer isn't memorize one Azure CLI command. It's understand the scope of the deployment and use the correct command for that scope. Now put your Bicep architecture under version control. A developer or infrastructure engineer submits a change to the repository. A CI/CD workflow validates the template. The pipeline can authenticate to Azure using workload identity federation such as OpenID Connect, avoiding long-lived deployment secrets. Then it deploys the Bicep architecture using the command appropriate for the template's deployment scope. After deployment, automated tests can validate important behaviors. Does the application respond? Are health probes healthy? Are expected routes working? Are WAF policies attached? Does failover behave as designed? Then your collaboration tools can notify the team about the deployment result. That's the real value of GitOps and infrastructure as code. Changes become reviewable, repeatable, testable, and auditable. Certificates are another place where architecture matters. You don't want private keys or sensitive certificate material embedded in your infrastructure code. For services and scenarios that support it, Azure Key Vault and Managed Identities can help separate certificate storage from your deployment templates. Application Gateway, for example, can use a managed identity to access supported certificates stored in Key Vault. Azure Front Door also provides certificate management options, but don't assume Front Door and Application Gateway use Key Vault in exactly the same way. They're different services with different certificate workflows. The design principle is what matters. Keep secrets out of source code. Use supported identity-based access wherever possible. Centralize certificate management where appropriate. And validate the exact implementation against the current documentation for the service you're deploying. Now let's look at security across the application path. At the global edge, Azure Front Door WAF can inspect HTTP and HTTPS requests for application layer threats such as SQL injection and cross-site scripting. If Application Gateway is also part of the architecture, it can provide regional WAF inspection when your requirements justify that additional security layer. Then, network controls, such as NSGs, can help restrict supported Layer 3 and Layer 4 traffic around your regional workloads. And identity controls determine which users and applications are authorized to access your services and data. Azure also provides additional DDoS protection capabilities for eligible Azure resources, but we'll cover those options in detail in the dedicated DDoS and Azure Firewall episode. For now, remember the bigger architecture lesson: WAF, network controls, identity, and platform protections. These controls operate at different layers, and you don't automatically need two WAFs just because Front Door and Application Gateway both support one. Every security layer should exist because a requirement justifies it. Time for a quick checkpoint. True or false? With Front Door's WAF enabled, you no longer need NSGs to secure your backend. Answer: false. Even with WAF, you still need NSGs as a defense in-depth measure. This is core to Zero Trust. There's no universal answer to which architecture costs less. Azure Front Door has its own base, request, data transfer, security, and feature-related pricing depending on the tier and configuration. Application Gateway has capacity and data processing considerations. Private connectivity can introduce additional charges. UWAF adds security capabilities and associated cost. Caching may reduce the amount of traffic reaching your origins, which can lower origin load and potentially reduce some data transfer or compute requirements. But whether that produces a net saving depends on your workload, so don't say, "Front Door is cheaper." Build the traffic model. Estimate request volume. Estimate data transfer. Determine how many regional gateways you actually need. Then use the current Azure pricing calculator. Architects optimize the complete architecture, not one line item. Caching can be both a performance and cost optimization tool. When Front Door serves cacheable static content from Microsoft's Edge, fewer requests need to reach your origin infrastructure. That can reduce origin traffic and application load. Regional services, such as Application Gateway, can also use autoscaling so capacity can adjust with workload demand. But neither feature guarantees a lower bill. Caching effectiveness depends on your content, cache rules, request patterns, and data transfer model. Autoscaling depends on workload demand and minimum capacity configuration. So measure before and after. How many requests reach the origin? How much data was transferred? How much gateway capacity was consumed? Cost optimization is an engineering exercise, not a promise. Traffic Manager and Front Door both support global traffic distribution, but they work very differently. Traffic Manager operates at the DNS layer. It responds to DNS queries according to the routing method and endpoint health you've configured. Traffic Manager doesn't sit in the HTTP data path, terminate TLS, inspect requests with WAF, or cache application content. Front Door is a Layer 7 reverse proxy. It sits in the HTTP and HTTPS request path and can provide TLS termination, WAF, URL routing, health-based origin selection, caching, and edge acceleration. For applications that require those Layer 7 capabilities, Front Door is often the stronger fit. But don't assume Traffic Manager is only for non-HTTP workloads. It can also be appropriate for HTTP and HTTPS architectures when DNS-level traffic distribution is what you actually need. Again, choose based on requirements. So when should Azure Front Door be high on your list? When you need global HTTP or HTTPS application delivery. When you need Microsoft's Edge network in front of globally distributed origins. When you need Layer 7 routing. When you need WAF at the global edge. When you need caching or application acceleration. Or when you need health-based global origin selection. Traffic Manager solves a different problem at the DNS layer. Application Gateway solves regional Layer 7 requirements. Azure Firewall solves centralized network security requirements. These services aren't interchangeable. A mature architecture may use several of them, but each one should have a clearly defined job. That's how you avoid building an expensive diagram full of overlapping Azure services. One valuable security pattern is reducing direct public exposure of your application origins. Azure Front Door Premium supports private link connectivity to supported origin types and configurations. Where supported, Front Door creates a managed private endpoint to establish private connectivity with the origin. But there's an important approval step. The origin owner must approve the Azure Front Door managed private endpoint connection before private traffic can flow. Once approved and correctly configured, Front Door can reach the supported origin through private link instead of requiring the origin to accept general inbound traffic from the internet. That can significantly reduce the origin's direct public attack surface. But private link isn't a universal switch that makes every possible front door origin private. Support depends on the origin type and architecture. So use this process. Identify your origin. Verify that the required front door private link architecture is supported. Configure the private connectivity. Approve the managed private endpoint connection. Restrict unintended public access where appropriate. Then, validate the actual traffic path. Private connectivity is powerful, but the entire configuration has to work together. Quick checkpoint. What happens when a front door origin becomes unhealthy? Front door health probes contribute to determining whether that origin should continue receiving new requests according to your origin group configuration. At the regional level, Application Gateway Health Probes monitor its backend targets. If a backend becomes unhealthy, Application Gateway can stop sending new traffic to it according to its health evaluation. Now remember, that's not the same thing as connection draining. Connection draining is used when a backend is being removed or updated and you want existing connections to have time to complete. Health probes detect health. Connection draining supports graceful removal, different tools, different jobs. Now let's test the architecture. In Azure Front Door, identify the origin or regional application endpoint you want to test. Depending on the current portal experience and your configuration, you can disable an origin or intentionally make the test origin unhealthy. Then watch what happens. Front door health probes detect the change according to the configured probe interval and health evaluation settings. Once the origin is considered unhealthy, Front Door stops selecting it for new requests according to the origin group routing configuration. Traffic can then be directed to another healthy origin. Don't memorize portal button names. The interface changes. Learn the behavior, create failure, observe health, verify routing, confirm recovery. That's a real resilience test. Application layer gateways can also help enforce security headers. One example is HTTP Strict Transport Security, HSTS. HSTS tells compatible browsers to use HTTPS for future connections to the domain for the configured period. But don't enable it blindly. Before deploying HSTS, make sure the application is fully ready for HTTPS-only access. Carefully evaluate settings such as max age, include subdomains, and whether the domain is appropriate for preload requirements. You can also use rewrite capabilities to remove unnecessary response headers or add other security-related headers according to your application requirements. Security headers are useful hardening controls, but they're part of a broader application security strategy, not a replacement for TLS configuration, WAF, patching, or secure application development. Architecture challenge. You run a global e-commerce application with both static and dynamic content. How might front door help? Static. Cacheable assets can potentially be served from front door's edge cache, reducing repeated requests to the origin. Dynamic application requests can be routed to appropriate origin groups based on URL patterns and health. Behind those origins, regional application infrastructure can perform additional routing when required. The important point is that you may not need to bolt a separate CDN into the architecture just to demonstrate global static content caching. Front door itself provides edge caching capabilities. Start with the simplest architecture that satisfies the requirement. Then add services only when they solve a specific problem. Now turn this lesson into a portfolio project. Build or adapt a Bicep template for a smaller version of this architecture. You don't need to reproduce every component from a large enterprise deployment. Start with 2 application origins and Azure front door. Add health probes and routing. If your lab requirements justify it, add application gateway to one or both regional environments. Then run a controlled failover test. Make one origin unhealthy and verify that front door stops selecting it according to your configured health and routing settings. Document what happened. Capture your architecture diagram. Explain why you selected each service. Include the security and availability trade-offs. And add a simple cost estimate based on your lab design. That's a portfolio project that demonstrates more than Azure product knowledge. It demonstrates that you can design, deploy, test, and explain an architecture. Now let's connect the technical lesson to your career. Whether you're coming from Helpdesk, desktop support, systems administration, or another IT role, the goal isn't to memorize more Azure services. The goal is to demonstrate that you can make architecture decisions. Take the lab from this video and turn it into evidence. Create an architecture diagram. Keep the Bicep in a source-controlled repository. Document the availability and security requirements. Explain why you selected front door. Explain whether application gateway was necessary. Show how health probes detect failure. Run a controlled failover test and capture the results. Then document what you would change before deploying the architecture to production. That's the type of project that lets you demonstrate architecture skills instead of simply claiming them. When discussing this project in an interview, focus on your decisions. Be prepared to explain why front door instead of traffic manager. Why application gateway instead of Azure load balancer? Did the architecture actually require both front door and application gateway? Where does TLS terminate and where is traffic re-encrypted? Where does WAF inspection occur? What happens when an origin becomes unhealthy? How is the environment deployed consistently? How is it monitored? And what are the major cost drivers? Those are architecture questions. Your portfolio becomes much stronger when you can explain not only what you deployed, but why you designed it that way. Let's lock in the technical lessons. Azure Front Door provides global Layer 7 application delivery at Microsoft's edge. It can provide health-based origin selection, WAF, TLS termination, URL routing, acceleration, and caching. Application Gateway provides regional Layer 7 load balancing inside your Azure networking architecture. It supports capabilities such as path-based routing, TLS termination, health probes, connection draining, session affinity, and optional WAF. Traffic Manager provides global DNS-based traffic distribution. Azure Load Balancer handles regional Layer 4 TCP and UDP scenarios. And Infrastructure as Code lets you represent these architectures in repeatable, reviewable deployments. The most important lesson: don't select services because they're popular. Select them because they satisfy a requirement. Here's the career takeaway. The difference between knowing Azure services and designing Azure architecture is your ability to explain trade-offs. An architect should be able to say, here's the availability requirement. Here's the security requirement. Here's the expected traffic pattern. Here's why I chose Front Door. Here's why I did, or didn't, add Application Gateway. Here's how Failover works. Here's how the architecture is deployed. And here's how we validate that it actually works. Your certifications can demonstrate knowledge. Your portfolio can demonstrate application. Build something. Break it. Test the recovery. Document the results. And be prepared to explain your decisions. One last checkpoint. A front door origin representing one of your application regions becomes unhealthy. What happens? Front door's health probe and origin selection logic can stop sending new requests to that unhealthy origin according to your configured health and routing settings. If another healthy origin is available in the origin group, traffic can be directed there according to the configuration. Because front door is a reverse proxy in the HTTP and HTTPS data path, Failover isn't dependent on waiting for clients to receive a new DNS answer in the same way a DNS-based traffic management solution is. But don't promise instant failover. Actual detection and traffic shift timing depends on health probe settings, routing configuration, connection behavior, and application architecture. That's the architect answer. Understand the mechanism. Then test the real recovery behavior. If this series is helping you build practical Azure skills, like the video and subscribe so you don't miss part 9. That's where we'll add more security layers to the architecture with Azure DDoS protection and Azure Firewall. And I'd like to hear about your experience. Have you deployed Azure Front Door and Application Gateway together? Or did your requirements allow you to use Front Door without the additional regional gateway? Share your architecture or lessons learned in the comments. Now, let's take a quick look at what's coming next. In Part 9, we'll add more network defense layers to our Azure architecture. We'll look at Azure's DDoS protection model and how Azure helps defend eligible resources against Layer 3 and Layer 4 attacks. Then we'll add Azure Firewall for centralized network and application traffic control, including network rules, application rules, threat intelligence, and traffic inspection. Most importantly, we'll talk about routing. Because deploying a firewall doesn't automatically mean your traffic passes through it. You'll learn how the firewall, route tables, hub-spoke architecture, and other security controls work together. That's next. Remember, careers aren't built by watching videos, they're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.